Hey everyone, welcome back to the channel. Have you ever looked up at the night sky and wondered where it all came from? Not just the stars and galaxies, but us, the ground beneath our feet, the air we breathe, the very atoms that make up our bodies. The answer is as poetic as it is violent. We are made of stardust, forged in the heart of dying stars. Today, we're diving deep into one of the most spectacular events in the cosmos, the supernova. This isn't just a story of cosmic destruction. It's the ultimate creation story. Let's start with a star, but not just any star. Imagine one much bigger than our sun, at least 8 times its mass. For millions, maybe even billions of years, this stellar giant is a cosmic powerhouse. Deep within its core, it's a nuclear furnace, relentlessly fusing lighter elements into heavier ones. It starts with hydrogen, the most basic element, and through immense pressure and heat, fuses it into helium. This process releases a tremendous amount of energy, which pushes outward, perfectly balancing the star's own crushing gravity. It's a delicate cosmic dance that keeps the star stable and shining brightly. But this dance can't last forever. As the star ages, it burns through its hydrogen fuel. The core contracts, gets hotter, and starts fusing helium into carbon and oxygen. This cycle continues, creating progressively heavier elements: neon, magnesium, silicon. The star's interior becomes like a cosmic onion with layers of different elements, the heaviest ones concentrated at the core. The final stage in this fusion chain is the creation of iron. And this is where things get dramatic. Unlike the lighter elements, fusing iron doesn't release energy, it consumes Italiano. Suddenly, the outward push from fusion that has supported the star for its entire life just stops. The music of the cosmic dance halts. In an instant, gravity wins. The star's core, a ball of iron about the size of Earth but with the mass of our sun, collapses under its own immense weight. We're talking about a collapse that happens in a fraction of a second, at speeds reaching a quarter of the speed of light. This catastrophic implosion is what triggers the supernova. The core collapses so violently that it sending a colossal shockwave hurtling back out through the star's outer layers. This shockwave is unbelievably powerful. As it tears through the star, the energy is so intense that it triggers a final, frantic burst of nuclear fusion. It's in this fleeting, violent moment that all the elements, heavier than iron, are created. Think gold, silver, platinum, uranium, all the precious and heavy materials we know. They are born in the final death throes of a massive star. The shockwave then blasts all these newly forged elements, along with the rest of the star's material, out into interstellar space. What's left behind is a beautiful, expanding cloud of gas and dust called a supernova remnant. It's a ghostly, glowing memorial to the star that once was. But this isn't an ending. It's a profound new beginning. This cloud, enriched with everything from hydrogen to gold, is now the raw material for the next generation of cosmic creation. Over millions of years, this enriched cloud of debris travels through the galaxy. It mixes with other interstellar gas and dust, further seeding the cosmos with the building blocks of, well, everything. Gravity, the same force that destroyed the star, now begins its slow, patient work of creation. It starts to pull clumps of this cosmic dust and gas together. As these clumps grow larger, their gravitational pull increases, attracting more and more material. Eventually, one of these clumps becomes so massive and dense that the pressure and temperature at its center ignite nuclear fusion once again. A new star is born. But this isn't just any star. It's a second-generation star, formed from the ashes of its predecessor. And surrounding this newborn star is a swirling disk of leftover gas and dust, the same material ejected by the supernova. This is a protoplanetary disk. Within this disk, the story of creation continues on a smaller scale. Tiny dust grains, coated with ice, start to stick together. It's a process called little grains become pebbles. Pebbles become rocks. Rocks become boulders. These larger bodies, called planet, continue to collide and merge, their gravity growing stronger with each collision. Over millions of years, these planetesimals sweep their orbits clean, gathering up material to form full-fledged planets. Some become gas giants like Jupiter, others become rocky worlds like Earth. And this is the incredible connection. The iron in your blood, which carries oxygen to your cells, forged in the core of a massive star just before it died. The calcium in your bones, created in the same cosmic furnace. The gold in a wedding ring, the silicon in our computers, the carbon that forms the basis of all life as we know it. Every single one of these atoms was synthesized in the heart of a star and scattered across the galaxy by a supernova. When our solar system formed about 4.6 billion years ago, it was from one of these enriched clouds. The sun, our planets, and everything on them, including us, are the direct descendants of long-dead stars. The very elements that allow for life, carbon, nitrogen, oxygen, were delivered to our corner of the galaxy by these explosive events. Without supernovas, the universe would be a much simpler and much more sterile place. It would likely consist of only hydrogen and helium, the elements created in the Big Bang. There would be no rocky planets, no water, and certainly no life. So, the next time you feel small looking at the vastness of space, remember this: you are not just an observer of the universe, you are a part of it. The cosmos isn't just out there, it's within you. Every atom in your body has an ancient, cosmic story to tell. A story of stellar fire and explosive death, leading to new life. We are, quite literally, children of the stars. The chronicle of a dying star is the chronicle of our own origin. It's a humbling and awe-inspiring thought, connecting us directly to the grandest cycles of the cosmos. Thank you so much for joining me on this cosmic journey today. If you found this as mind-blowing as I do, make sure to hit that like button and subscribe for more explorations into the wonders of our universe. Let me know in the comments what cosmic topic you'd like to dive into next. Until then, keep looking up.